So now in this video we're going to make a little more practical circuit with the inverter using an integrated circuit with inverter. So this is an old diagram. I'm reusing an old circuit, but I really like this one, so we're going to go with it. So we got the 4049 here. So this is the 4000 series integrated circuit. Lately I've been using the 7400 series integrated circuits. And the hex inverter here, there's 6 of them, but there's 2 more pins on this integrated circuit than the ones we've been looking at lately. So a couple of them aren't connected to anything. You just leave them alone. So we're going to use a couple of them here. So it has the basic property, the inverter, of the output being the opposite of the input. So if you have a high input, if it's 5 volts, then you can expect 0 volts at the output. That's the main property of the inverter. If the input is low, 0 volts, right there, then the output will be high, so as close to 5 volts as it can output. What we're going to do is put them in series. So if you take away this circuitry, if that's high, that's low, then that will be high. If you feed it right back, it's going to stabilize. It's going to hold its position. But here you can see we have a capacitor that is feeding it back. So when that's high, well, the capacitor is charging, that will be high as well. But at some point it's going to level off. And then so we got high, low. You can see that this will start pulling it low over there. And once it gets it low enough, then that will set that high. That'll be low. The capacitor will be charging the other way, helping to hold it low until it gets so low that all of a sudden the high here pulls it up. And the process just keeps repeating. So hopefully that made sense. But in any case, we'll have the output changing high and low here. It can power an LED, so we're going to see the LED flash. Since we're using 5 volts, you don't always see the voltage. You could also put it there, but because each one of these inverters is working on the same power supply. But in any case, we're going to work with 5 volts, 220 ohms. So that's another thing with the 7400 series integrated circuits I've been using lately. The positive side of the power supply has been up here, although there's only 14 pins, but it's in that corner with negative to that one. With at least this particular integrated circuit, we have the positive supply on top and the negative supply down there. So we got VDD because it's using MOSFET transistors in there, and VSS, again, because of MOSFET transistors in there. This could be positive supply and ground. Maybe different data sheets have different listings, but apparently that's the one, what the one I had said. And you can see we got A there for that inverter, B, C, and it looks like you start down here, D, E, F, if you need to keep them labeled for some reason. And so here we have the circuit in action right there. I have current limited to 20 milliamps so we don't damage anything, 5 volts if we short circuit or something. So we're using the 4049 that I got from this integrated circuit kit right there. So I put links to what I use in my Amazon shop. There's links down in the description. Also on my webpage, I linked this kit quite a bit with the other 2. And so in any case, there we can see that it is flashing. If you use those links before you make any purchases, a lot of purchases will help me financially without costing you anything extra. So here we have the powering it, pin 1 to the positive supply, pin 8 to the negative supply. So we got the output there, 220 ohm resistor to the LED. You can see it flashing. So it's output, input, output, input. And so we have to connect the 2 together. There's a little jumper there from the output of that one, the lower one, to the input of the higher one right there. They're connected directly together. And then we have the capacitor. So that's going to the output pin 2 to the input of the other one right there. So as it charges and discharges, it's given an opposite signal to that input, which is why the output up here is oscillating, because they are in series really. So then we have this resistor here. So the capacitor either charges or discharges, but it needs the resistor for the oscillation right there. And that's because the output up there wants to be the opposite of what the input is. So once the capacitor is not doing anything anymore, all of a sudden you have the output here, the opposite of the input, and that overpowers the signal that you might still be getting from the capacitor at some point and flips it and gets the process going again. And finally, I like to look at the output voltages. So we have the oscilloscope there. We have the alligator clips, clip 2 jumpers right there. And we will zoom in. So you can see here that although we are using a 5-volt supply right there, we are not getting 5 volts at the output. But we are definitely going all the way to ground. And so if we remove the LED, now you can see we are getting 5 volts right there. So it's not really intended to power anything, especially if you need the full voltage. You would use that to an amplifier where it'll take that voltage and do something with it, like turn a transistor on and off or something. But you can power an LED a bit. So in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos that I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out a ton. Links down in the description. Just watch as many videos as you can though. Helps out a ton too. So thanks for that. I'll see you in the next video.